All right, guys, we got a super quick video here on some stuff related to differential equations. We very briefly looked at this during the school year, so you may not remember this. But I've got a question up here. It says, which of the following are solutions to this differential equation? It's got a second derivative, it's got a first derivative, and it's got the original function. And it says, if we add these together or subtract, which of these is going to equal 0? So if you get a question like this, it's usually going to be like a three-part question. We've got to check all three of these, and hopefully they give us ones where the derivatives aren't too bad. So I went ahead and took the derivatives of each of these. I found the first derivative and the second derivative. I'm not going to go over those. You guys should all know these derivatives right here. And then what I'm going to do is I'm going to check one at a time. So I'm going to check one first, and I'm going to plug in e to the x for y, e to the x for y prime, and e to the x for y double prime, and see if the whole thing comes out to 0, since this one's equal to 0 here. And so if we did that, all right, if we did that here, again, it would look like this: e to the x minus 3x plus 2, or 3e to the x plus 2e to the x. So these two add together to give us 3e to the x, and then 3 minus 3 is 0, so it did in fact equal 0. So this one is a solution right here. If we did it with the other two, if I plugged in y double prime, y prime, and y into this equation, it would look like this: 0 minus 3 times 4 plus 2 times 4x. This is not going to simplify to 0. It does not simplify to 0. So this number 2 is not a solution. And then if I plugged in all three of these into the respective places, it would look like this. We'd have 3 terms. There's 2 you can combine, but that's really it. So you get negative 3 times cosine of x. This adds to plus sine of x. And there might be one value of x you could solve for, but we want this to work for all values of x here. So this is not a solution either, and is just option number 1 here. All right, the last thing I just want to remind you guys about is matching slope fields to differential equations. So a slope field is going to have way more slopes than this. I'm just highlighting 4 points that I think are good ones to check. These are not the only points on a graph. There might be other ones. You might want to use one like 1, 0 or whatever the slope looks like. I only gave us these 4 here. It's going to be enough for the one that we're doing. So what I do is I pick a slope. I'm going to pick this one, okay? And I'm going to say the slope is about 1. I know it's a positive number. I don't know that it's 1, but I know it's a positive number because it's going up to the right. All right, so I'm going to take the coordinate point here, which is right 1 and up 1, and I'm going to plug in 1, 1 to these derivatives, and whichever ones give me 1, I'm going to keep, and whichever one gives me a positive number, I'm going to keep. If it gives me 0 or a negative, I'm going to get rid of it. So if I plugged in 1 for both of these, 1 times 1 is 1, so we're going to keep this one. 1 times 1 squared is 1, we're going to keep that. But here I'd get negative 1 if I plugged in 1 for x, or if I plugged in 1 for y, I'd get negative 1 as well. So we're going to get rid of c and d. And now I just kind of pick one. We got a few options. I'm going to try this one. So at the coordinate point 1, negative 1, there's a negative slope here, right? M is less than 0. It might be -1 or something like that, but we don't know the exact value. So I'm going to plug in 1 for x and negative 1 for y, and I get negative 1 here. 1 times negative 1 is negative 1. But here, if I did 1 times negative 1 squared, squaring the negative makes it positive, times 1 is 1. But we had a negative slope, so it's not B. A would be the answer of this one right here. All right, so that's my strategy for these differential equations here. You do not have to separate the variables and take an antiderivative of both sides. That would be actually finding the solution. We just want to match the derivative to its slope field. All right, guys, that's it. Like I said, super short video. And hey, stay flawless.